Today's lesson is about not necessarily using studies wisely. That's what the book tells us it is. But really, this lesson is about this concept right here. Scope of inference. Scope of inference. So what does scope of inference mean? Well, let's kind of backtrack. We talked about inference. Inference is drawing a conclusion based off of some estimate. Drawing a conclusion about a population based off of some estimate. Right? So that's an inference. So what we're looking at today is what can we make an inference about based on how the study was designed, either an observational study or an experiment. How can we, what kind of conclusion, what kind of inference can we make? And that's determined by two factors. And the two factors are in the design of our study. The first factor is were the individuals randomly selected from the population? Okay? Did I take a random sample from the entire population? Okay, that's the first question. And I can answer yes or no for both of those questions. Okay. The second question is, were individuals randomly assigned to groups? Were individuals randomly assigned to groups? That's the second question. Again, yes and no for both of those questions. So let's start in the very negative, and there's 4 boxes, 4 different types of studies that we can have. The first one is I can answer no to both of those questions. I didn't randomly select from the population, and I didn't randomly assign to groups. So if I didn't randomly select from the population, that would be something like a convenience sample or a voluntary response sample. Okay? And if I didn't randomly assign to groups, that means I'm doing an observational study. Okay? I'm not imposing any treatment. Okay? So we can make 2 types of inferences. We can make an inference about the population. We can make inference about a cause and effect relationship. If I don't do an experiment, I cannot make a cause and effect inference. Okay? So if I answer no to both of these, no way can I say I made a cause and effect inference. And then since I did not randomly select from the population, I can't make an inference about the population. Okay? That is a bad study design. Okay? We never want to be there. We never want to be in that box. Okay? That box is bad. All right? So what if I answer no to the population question, but yes to the randomly assigned question? That would be in this box down here. Okay? So if I don't randomly select from the population, but I randomly assign to groups. So this would be like if I had volunteers volunteer for an experiment, and I randomly assign them treatment. Okay? That would be this. This is most experiments. Most experiments are in this box. Okay? Because generally in an experiment, we're not going to randomly select from the population. Because what you're doing is you're saying the entire population has to agree to be a part of your experiment.
But it can be a smaller population. Let's say
it could be if it's a smaller population. Yeah, then I can.
All the 50 to 60-year-old males in Georgia.
That's a lot. Okay. Right. So that would be a lot of population. It'd be hard for me to randomly sample from that
all
to do an
them
experiment.
in a square mile of.
I mean, if we did all 12th graders at GAC, that's 170 people. Maybe we can say, okay, do you guys let's be a part of the experiment. We want to see something about the senior class. Then we randomly select 20 from that class to be a part of our experiment. That's where I could something like that. But what inference can I make? Since I did not randomly select from the population, I can't make an inference about the population. Okay? I can only make an inference about the people or people like the people that are in the study. But since I randomly assign to groups, I assign treatment, I can make an inference about cause and effect. Okay? That is where most experiments are in. Okay? Top right, what if I say no to the randomly assigned groups? but I randomly select from a population. This means I'm not imposing any treatment, so we're conducting an observational study. So we can't make a cause and effect inference, but we can make an inference about the population. Okay? That is where most observational studies lie. So if I was trying to estimate the average height of the student population at GAC, I would randomly select from that population, get those people that I sampled's heights, and then I can make an inference about the population, make some conclusion about the population's height. Okay? But I didn't randomly assign to groups. I didn't impose a treatment, so there's no cause and effect relationship in that scenario. Okay? Now, top left, it's like the unicorn study. Doesn't really exist. It can, but this is where it's like the best of the best experiment. Okay? We randomly select from the population, and we randomly assign to groups we're doing this experiment, so we can make inferences about the population and cause and effect. Yeah.
Can't you make an inference about cause and effect for the observational if every, let's say, it's smoking and cancer. If you didn't give them to anyone,
right. So
but
for
100% of those that smoke, like in a hypothetical.
Right. So for those like examples where we can't ethically conduct an experiment, using an observational study over a long period of time, we can start to talk about a cause and effect relationship. For the scope of this class, we're going to say no. Okay, but there are ways, yes, because we can say that smoking causes lung cancer, but there's no way that we did. There's no way that we did this or this, right? So I totally understand that question, but yes, in this class, talk. Any questions on that? So let's go through some examples, okay, and we'll get an idea. So raise your hand if you like to listen to music while you study. You think it helps relax you, right? Anybody listen to like heavy metal? No, while they study. Mostly classical. Okay. So I have an example here. We have 4 scenarios, 4 different study designs, and we're going to talk about what we can infer from those studies. Many students insist that they study better when listening to music. I certainly like listening to music when I study or when I work. A teacher doubts this claim and suspects that listening to music actually hurts academic performance. Here are 4 possible study designs to address this question at your school. In each case, the response variable will be the student's GPA at the end of the semester. For each design, we're going to suppose that the mean GPA for students who listen to music while studying was significantly lower than the GPA for students who don't listen or didn't listen to music. Okay? What can we conclude for each design? So just hypothetical scenario. This isn't a real study. Okay? So if you listen to music while studying, keep doing it if you want to. Okay? This is not real. All right? So we're just going to assume that the GPA for the students who listen to music was worse. Okay? In each of these designs. So what can we infer? So the first study design, we get all the students in your AP statistics class to participate in a study. Ask them whether or not they study with music on and divide them into the 2 groups based off of the answer to the question. What can we infer from this study design? Did we rank? What's our population, first of all? The school. The school. The school. So did we randomly select from the population?
No.
Convenience sample, right? Our AP stats class. Did we randomly assign to 2 groups and impose some treatment?
No.
What can we infer?
Nothing.
Absolutely nothing. This is where we don't want to be. Okay? We can infer nothing from this study. Okay. So number 2, select a random sample of students from your school to participate in the study. Saw the word random, that's great. Ask them whether or not they study with music on and divide them into the 2 groups based off of the answer to this question. So, did we randomly select from the population?
Yes.
Did we randomly assign to 2 groups?
No.
So we can infer only about the population that students who listen to music while studying tend to have a lower GPA. We cannot say that listening to music causes a lower GPA. We can just say that in our population, students tend to have a lower GPA when they listen to music. Okay, we can infer about the entire population. Okay. Still good? Number 3. Get all? Do we have to go back? Sorry. My bad. Good. Number 3, get all of the students in your AP Statistics class to participate in the study. Randomly assign half students to listen to music while studying for the entire semester. Have the remaining half abstain from listening to music while studying. So, still a convenience sample, or in this case, probably a group of volunteers. Okay, our AP Statistics class volunteered for this. But we randomly assigned a treatment. Half the students got no music, half the students got music. So, we can say that, and this is really kind of an important distinction. We can infer that music causes students to have a lower GPA for students like those in your AP Statistics class. That's an important distinction. It's not, yeah. This would be a cause and effect. I can say that listening to music causes lower GPA, but only for the students who are like those in your AP Statistics class. Why is that the case? Well, I didn't do the entire school, right? Your population in this AP Statistics class is probably a little bit different than the entire student population. I'm assuming that most of you are taking multiple APs or have taken APs before, so you might be a different level of student than other students in the school, and might react differently to music than other students in the school. So students like yourself, we can apply this cause and effect relationship. Yeah.
Are we assuming the 5% thing?
Yeah, we're assuming that it is the results that we got were statistically significant.
Okay.
Yes, we are. Okay, last one. Select a random sample of students from your school to participate in a study. Randomly assign half the students to listen to music while studying for the entire semester, and half abstain from listening to music while studying. This is the perfect experiment. We got random sample from our population. We randomly assigned treatments, and we followed through, and we got the results that we wanted. We can infer a cause and effect relationship for the entire population, the entire school. We can infer that for that population of our school, that music causes students to have a lower GPA. Again, not easy for us to do, right? That would take a lot of work and a lot of follow through to be able to